So the deal is, this is what Deb and Jeff use to stay warm. You got a heater here, one here, one there. If you ever seen them, they're actually natural gas driven, and it heats a ceramic honeycomb. We used to call it kind of like radiant heat, but there's another word for it. Wow, look at the different color in the ocean out there. Anyway, the problem is this part of the heater is made out of stainless steel. Now, I couldn't tell you what grade it is. It ain't probably the best because you can see it rusting. This is from heat. And combined with the heat and rust, what's happening is the stainless steel is taking a beating from the salt from the ocean, right? It messes up all the connections. You can see here where it's turning green. And the original problem is there are electronics in here with brass and copper contacts. So when the juice runs through there naturally, it's like a magnet for the salt, and it has really taken a toll. And we literally had to replace all the electronic controls. So the game plan was for this year, we wanted to try to remove the controls, label them, and put them away. So at least, you know, for most of the season, they're not being attacked by salt. And that's what we're gonna do. We're gonna do a three-part process. We're gonna move the controls, label them, bag them up, and then next year when they come back, we'll put them back. And that's the only longevity I believe we're gonna get out of it. The second thing is, when these units were assembled or at the factory, they used aluminum rivets. See here? Notice down here, the rivet is gone, see? See? So although the metal could withstand a little bit of salt and punishment, everything that's a screw in here, they used materials that really attract the salt, and they are just being eaten alive. Here's another hole. That's the hole where a screw should be. So what I'm gonna do is put some screws in there that are stainless steel, and hopefully that will again have a little more longevity. So that's step one, label, remove controls. Step two, put some kind of fastener in here that's going to withstand the salt a little better. And step three, you know what, the gas, it's outside, the gas doesn't have to be turned off. The third problem I found with this installation, here again you can see the rust if you're eating, is this. Whoever installed these for me used this. This is regular steel, or what they call mild steel, or what we call black malleable. That's actually the proper term. Notice this isn't rusted. This would be galvanized. What should have happened, I see galvanized here, thank goodness. All of this should have been galvanized. This hose is still in good shape. I don't see it cracking. The gas valve in this unit was replaced. That was the last thing we did. So eventually what I'd like to do for longevity and get the most out of these units before they have to be replaced, which is more of an expensive deal, one day is to replace these with this type so it doesn't rust, because I guarantee you this will eat right through, and on natural gas, that's a problem. On this one, the valve, I remember, oh, I can turn it. You know, because it's under this cap, it's probably still working pretty good, but I would like to replace this, the valve. This hose is okay for right now, and that's it for this unit. The other units, I believe it's the same thing going on. But anyway, that's it for this video. It gives you an idea of what our intentions are and our attempt to get the best out of a situation where the installation should have taken, or as we say in the industry, leaves much to be desired. And it's a shame because good folks like Deb and Jeff have to suffer from, you know, people who just don't care. See you on the next one.